next speaker, and that is Michael Watson, and he'll discuss the topic of recurring central solar eclipses at one location. Go ahead, Michael.
All right, everybody. Well, thank you, Paul, very much. It's nice to be back speaking with the Toronto Centre. Again, I was a member of the Toronto Centre many, many years ago. I think some of you may have seen me before at Toronto Centre meetings. I joined the RESC, believe it or not, in 1970. So I am now in my 53rd year of membership, and I'm a director of the society and first vice president. But I'm not here to talk about that tonight. What I'm here to talk about is this. The next 62 weeks are going to be really fairly remarkable for North American astronomers. And the reason for that is that there are going to be two central solar eclipses visible across North America. We have one coming up in just 8.5 months, so mark your calendars. This is an unusually long annular solar eclipse that will be visible, and I will show you where. You probably already know this, in October. And then at the next eclipse season, which is in April, just a few months after that, we will then have the 4-minute, and this is the second so-called great American eclipse, 4-minute total solar eclipse across Mexico, the US, and then coming into Canada over Niagara Falls and then across Lake Ontario, just barely missing Toronto, and then going over Kingston and further east. So these are two really important eclipses. And as I was thinking about these, as I have been, frankly, for a long time, because I remember that in 1970, when I joined the Astronomical Society, RESC, people were already talking about the great eclipses of 2017, which, of course, many of us will have seen 6 years ago, and then the even longer total eclipse of 2024, all the way back then, over half a century before they were going to take place. And so I was thinking about these eclipses, and I realized that their paths were going to cross. And so I thought, I've been interested in this for a long time, and I thought that I would just do a little post up on the ASC list, Rascals, and then when that went up, I was asked to speak about this. So here I am. And what I'm going to talk about, and what I want to, is just, first of all, do some acknowledgments, because I've taken this information from a lot of sources. One of the great ones and one of the great names in mathematical astronomy is Jean Meus, who's a Belgian meteorologist, retired now, born in 1926, and he has written a series of books in mathematical calculations. And the one that I like, the first one from 1997, is called Mathematical Astronomy Morsels. And there have been 5 versions of this come out, and he talks a lot about eclipses and some really, really interesting information about them. So he's the first acknowledgement I want to give. And then Fred Aspanack, probably the world's most renowned and greatest eclipse calculator, who I also really call a friend, because I got to know him back in 1970, and he and I observed the 1994 annular solar eclipse in Ohio together. Fred's just a great guy. He worked at Goddard Space Flight Center for many years before his retirement, and he runs the website Mr. Eclipse, which you should go to. Fantastic photographs, information, everything you need to know about solar and lunar eclipses. And then finally, Xavier Joubier, who is a French astronomer, and he has put together a website in which he has on Google Maps information for all of the eclipses. You can see live all of the eclipse paths and so on. Zoom in, find the local circumstances for any eclipses in the modern era. And I use this all the time, and you'll find a great deal of information there and very useful maps. So those are the acknowledgments. And so we all know this, and I think we probably all learned this when we were, I don't know, about 3 years old, the geometry of solar eclipses. We know, of course, that, and I'm going to simplify this somewhat, but that the moon orbits a planet Earth not in a perfect circle, but rather in an ellipse. And sometimes it's a little further away than usual, in which case it appears smaller in the sky. Sometimes it is closer to Earth. We call it perigee. Apogee, further away, perigee, closer to Earth, in which case it is somewhat larger. One of the things I learned when I was very young is that one of the most, and maybe the most, fantastic and amazing coincidences in nature is that, as seen from the surface of planet Earth, the sun is about 400 times as far away as the moon is on average, but also almost exactly 400 times its diameter. And therefore, they appear from the surface of our planet to be approximately the same size. And therefore, when the moon happens to pass in front of the sun, depending on whether it's at apogee or whether it's at perigee, we can see either an annular eclipse if the moon is farther away. So there is still left uncovered. The moon isn't quite large enough to cover the bright photosphere or surface of the sun. And that leaves a thin annulus in Latin, or ring of unobscured sunlight still around. If, however, the eclipse occurs, a central eclipse occurs, with the moon passing directly over the sun, and the moon is in that part of its orbit where it is close to perigee, the moon is slightly larger than the sun, and therefore it blocks out the bright surface of the sun completely. And at that time, and at only that time, without special equipment, we can see the sun's corona or atmosphere. And so we can see these here. This is an annular eclipse, and you can see over here, if you can see my cursor, that the shadow, the umbral shadow, moon's far enough away that the umbral shadow, the cone of the shadow, doesn't quite reach the surface of Earth. And so for someone on the surface of Earth, what you actually see then is that thin annulus. Whereas with a total eclipse, you can see here the moon is closer to planet Earth, and therefore the shadow cone actually reaches Earth, and we can see in this very narrow little path that goes across the planet as moon moves in its orbit, people situated within that area will see the sun completely obscured. People located to the north or to the south, because of parallax, will see the moon shifted to the north or south of the sun, and it'll miss the center of the sun, and we will not get, and you will not be able to see a total eclipse. You'll see a partial eclipse from those locations. That's the basic geometry of a solar eclipse. And by the way, it is a misnomer. It's not an eclipse at all. They're actually occultations. Eclipses are when something falls into the shadow cast by something else. And so, for example, a lunar eclipse is properly called that. They're actually solar occultations. They both disappear, but that's the geometry is somewhat different. Okay, so let's talk about the frequency of these. How often do they happen? Well, we hear all the time in the news media that eclipses are rare. This is rare. Everything is rare. Well, not actually so much in this way. So Fred Espenak did a study of 5,000 years of solar eclipses. And as it indicates here, his study showed that there are almost 12,000 eclipses during that period of time. And we can see that most frequently of all of those eclipses are the partial eclipses. Partial as seen from some place on Earth's surface, accounting for about 35% of all of the solar eclipses. Annular eclipses, as we can see, account for almost exactly 1/3. Somewhat less frequent are total eclipses. I'm going to get back to that in just a moment. Just a little over 1/4 of all eclipses are total, and then a very, very small proportion are hybrid eclipses. I'm not going to talk about that too much. What that means is that at the ends, the start and the end of the shadow as it crosses planet Earth, it's an annular eclipse. In the middle, it's a total eclipse, a very brief total eclipse. And the reason why annular eclipses are more frequent than total eclipses is that on average, in its elliptical orbit around Earth, the moon is just a little too far away to be able to cover the sun in its entirety. And what it indicates then, therefore, is that about 60% of the time the moon's too small. It's only at that portion, only about 40% of its orbit where it's close enough so that if it passes in front of the sun, it's large enough to cover the sun completely. So total eclipses of the sun are less frequent than annular eclipses of the sun. And what we see here, sorry, let me just go back. We see then that someplace on Earth's surface, there is a total eclipse of the sun visible every approximately 1.6 years. So approximately 2 total eclipses every 3 years, someplace on Earth's surface. For annular eclipses, they're more frequent, 1.25 years. We see partial eclipses even more frequently than that, just a little over 1 year on average. Hybrid eclipses, you got to wait a long time to see anywhere on Earth's surface. And so there is a solar eclipse of some kind visible on average from someplace on Earth's surface every 153 days, or more than twice a year. There have to be 2 solar eclipses in every calendar year. There can be rarely up to 5. Now, it's sort of, we wonder, well, it should be the same in both hemispheres, isn't that right? Well, the answer is actually no. The relative frequency of annular and total eclipses is not actually the same in the northern and the southern hemisphere, and I'll tell you why. So there's the answer. Several answers, and they're all no. And the reason for that is that if we consider northern hemisphere summer, which is starting at the end of June, at that time, the Earth's axis is tilted so that the northern hemisphere is more directly facing and tilted toward the sun. Therefore, just naturally, more eclipses are going to occur in the northern hemisphere than the southern hemisphere. 6 months later, after Earth has rotated or revolved around the sun, it's the southern hemisphere that will be more directly tilted toward the sun, and there will be more eclipses in the southern hemisphere. And you should think, well, they should balance each other out for totals and annulars. Well, not quite. Why? Because in our summer, in the June-July period, the Earth is furthest in its orbit, because Earth goes in an elliptical orbit as well, furthest in its orbit from the sun. The sun is slightly smaller in size, and so there is a greater chance that if there's an eclipse, the moon will be in that part of its orbit where it's big enough to cover the sun. And it's because the Earth is as far away as it is. That's why there are more total eclipses visible from the northern hemisphere proportionally than in the southern hemisphere, because in the December-January period, Earth is closer to the sun appears larger, the moon is less frequently able to cover the entire surface of the sun. So that's why there is this difference. And this can actually be shown quite well here. This is information then for a period of about 600 years from Jean Maes. And I've reproduced it here. And what we can see is, if I can do it here, there we go. What we see then is that you get on average, a total eclipse once every 375 years all over planet Earth. That's actually been updated in his more recent book to 381 and a half. So it's slightly less frequent. But an annular eclipse is visible, 2 annular eclipses are visible from any one location on Earth's surface about once every 224 years. So they are more frequent. What we see here then, however, and we see here on the left from minus 80 degrees latitude all the way up to the equator at 0 degrees and then into the northern hemisphere, is that at 80 degrees north, we get then one total eclipse from a particular position at the location at 80 degrees north every 254 years. Whereas at 80 degrees south, it's about half as frequently, once every 513 years. And we get it then, approximately equal, in the middle. Now, when we talk about annular eclipses, not surprisingly, and I won't go into the geometry, but annular eclipses are much more frequent near the poles. At the equator, you see on average an annular eclipse recurring at any one location about every 279 years. And so there is a difference between northern hemisphere and southern hemisphere, and of course we know what the photos of these eclipses look like. I'm just going to show 3 of Fred's. We see a partial eclipse, of course, must be taken through a solar filter, and you can see the color of the filter here itself. This is from his website. An annular eclipse, and that's very much what it looks like through a telescope with a solar filter. And then one of his photographs of a total eclipse, the only time we can actually see the corona. All right, so moving on. And this is one of mine, by the way. This was back in 2013, very, very small partial solar eclipse, only about 3 degrees above the horizon, photographed from the Hearn Generating Station on the lower shore of Lake Ontario here in Scarborough. Another one, partial solar eclipse, again at low altitude. I really just love photographing them like this at low altitude, which is up in Muskoka in 2014. This was my photograph of the annular eclipse that I saw with Fred in 1994 in Ohio in May. And then you remember in June of 2021, there was an annular solar eclipse that was visible in northern Ontario and then across the Arctic. I couldn't get there, but it was visible as a large partial eclipse here from Toronto. And so this was on the shore of Lake Ontario. And then back in 1991, total eclipse from France, just north of Paris. And so what we see here, Fred Espenac has done a really nice job in putting together maps for 20 years showing in these 20-year periods all of the eclipse paths across planet Earth. And we see the blue ones, which are total eclipses, and the red ones that are annular eclipses. And interestingly here, you can see in this 20-year period, decidedly more total eclipses in the northern hemisphere and more annulars in the south, which is exactly what I was talking about a little bit earlier. This one of July 10th, 1972, we'll be talking about just a little bit more, came across Canada. That was the very first one that I went to see. I've been to see 9 total eclipses and 4 annular eclipses, and I've been clouded out of only 1 total eclipse, and it was my first one. And I knew at that time that I would have to wait 7 long years to see another one, and that was this one, the February 1979 eclipse that crossed here. So that's one. Let me just go through these, and we can see then from 81 to the year 2000, 20-year period. We can see the 1994 annular eclipse that went across a large swath of the U.S. Then we go forward to 2001 to 2020. Not an awful lot of action in North America, except the great American eclipse of August 2017, which many people went to into the path of totality to see. And of course, it was visible, I think, in clear skies as well here in Toronto. I was in Nebraska to observe that eclipse. And then we go on just to the last one. Well, actually, not the last one. I guess, yes, 2021 to 2014. And what we see here are 2 very large annular eclipses, but that's because they're projected onto the inclined surface of Earth in Canada, but in the northern regions. And then, of course, we get the great solar eclipse, the total eclipse of April 2024, which now is just 14 months away, 14 and a little bit months away. So let's then take a look at these eclipses that cross North America. We're going to get very shortly to ones where the eclipse paths cross, which is what this talk is really all about. And so between 1963 and 2024, which is next year, what I'm going to show here are total eclipses in red and annular ones in yellow. The annular one's in yellow only because you see some yellow sun on the, in the ring, and I just wanted to to sort of show it that way. So this is the July 20th, 1963 solar eclipse, which I saw as a kid at camp with as a partial solar eclipse with smoked glass that my father had given me back then to take to summer camp so that I could watch this. And of course, that's completely unsafe now, but who knew back then? So that was in July of 1963. Then in March of 1970, and this was just a couple of months before I joined the RASC, this was the first great American eclipse, probably the most widely observed eclipse to that time. Ever, because it received great publicity, and of course it passed across the southern U.S., southeastern U.S., south of Washington, and a lot of people saw that one, and it received a lot of press at that time. And as you can see, it also crossed Prince Edward Island, and we'll be talking about that a little bit more. Then the next one is the July 1972 eclipse, and that's the one I went to see. It was clouded out of. I was actually on the north shore of the south shore of the Gaspé, right here at a little town called Kapchat. What you can see here is that these 2 eclipses cross the paths of the March 1970 and July 1972 eclipses crossed here. And so within a period of 17 months, lucky people who happened to be located within that little diamond shape, we'll talk about this a little bit more, were able to see 2 total eclipses in less than a year and a half. Then we get to the 1979 eclipse. This is the one we saw from Gidley, Manitoba, the first one I actually saw. We organized an expedition and chartered 2 aircraft to see that one. It was very successful. Then in 1984, there was a very short annular solar eclipse, which was very special in its geometry. I won't get into that too much, but we went to Virginia to observe that eclipse. The great long 6 and a bit minute total solar eclipse across Mexico. Again, we hired a jet aircraft to fly to that one. A very famous eclipse a lot of people saw. Then in 1992, we actually went to Catalina Island to try to see this annular eclipse that ended with the sun about 1 degree above the horizon, just a sunset, but we were clouded out of that one, unfortunately. And then 1994, there's one I had mentioned earlier that I saw in Ohio, quite a long annular eclipse right across the middle of America. The 2017 eclipse that we all know about and many of us saw. Then a year and a half ago, the 2021 June annular eclipse in northern Canada. And then this coming October, another fairly large and lengthy annular eclipse crosses the western US. And finally, in April 2024, the great one that we've been looking forward to since 2017. And what you'll see here is that the 2013 annular eclipse and the 2014 total eclipse cross here in Texas. And a lot of the towns there, little towns, are already have websites for that, and they're talking about being the eclipse capitals of the world, etc. So I'm going to talk very briefly about these three. So central solar eclipses, if they can either intersect with 2 total eclipses or total and an annular one. There can also be 2 annular ones, but not in the recent era in North America. Probably the best known from those of us who have been hanging around and those of us who are familiar a little bit with old 1970s music are the total solar eclipses of 1970 and 72, both of which were visible from the same area in Nova Scotia. And so what we see here then is the first one that I showed before, March of 1970, with that path crossing up the eastern seaboard and then across Nova Scotia in the afternoon. And then the July 10th one that also was in the afternoon that can be seen crossing the same area of Nova Scotia. Looking closer then, we see Halifax and Truro, New Glasgow and Antigonish and Sydney, Cape Breton Island up in the upper right. And here we have the path then, the path of totality of the March 7th, 1970 eclipse. And then just a year and a half later, approximately, we see the other one, July of 1972 crossing. And within this area then, this diamond area, people located there in Antigonish and so on, and especially in Gainsborough here, near the Canso Causeway going out to Cape Breton, could see 2 total eclipses within this period of time. And here we see that the area of this was approximately 100 kilometers in width here and approximately 50 kilometers here. So you multiply 100 by 50, and what you're talking about then is some thousands of square kilometers of area in Nova Scotia where within a year and a half, 2 total eclipses could be seen. Interesting thing about them is that for the March one, these were both fairly short eclipses. 2 minutes, 17 seconds for totality at this part of the eclipse. It was in the afternoon. The sun was fairly low, 28 degrees, not surprisingly, because A, it was in the afternoon, and B, it was in March, even before the spring equinox. In July 72, year and a half later, the duration was even shorter. It was only a 2-minute, 5-second eclipse as seen from this location. The sun was just a little bit higher in the sky, not surprisingly, because it was Northern Hemisphere summer. But because it was so late, it was just before 6 p.m. in the afternoon, daylight time, obviously, the sun was actually fairly low, only 30 degrees. And it was this eclipse, the July 1972 eclipse, that of course Carly Simon sang about in her famous song "You're So Vain." to see the total eclipse of the sun. It wasn't the 1970 eclipse, it was the 1972 eclipse. That song was released in November of that year, just after this event, a few months. So then we go on to more recent events. And Paul, I am looking at the time. I think I got about 8 more minutes. So one in the recent past and one in the near future. And we have the eclipses of 2017 and 2024. And these are, again, both total eclipses. And just to remind us, this was the one that many of us saw in August of 2017. And here I am at my observing site in Nebraska with my family. Got some photographs of this one, which I was actually really pleased with. We drove all night because where we were 500 kilometers to the east in Grand Island, Nebraska, it was cloudy. And we drove through the fog right to the almost to the border of Wyoming, set up and managed to see it in the clearest sky I've ever had, actually, for a solar eclipse. And so that was my view of totality there. And a somewhat blown up view then of prominences on the edge of the eclipsed sun. It was a great event. Okay, so going back, that was 2017. Are we going to see another one that is as good as that one in 2024? We can hope. And so here we have then the intersecting paths. And now it's 7 years apart, not 17 months, but are almost 7 years apart, where people in a number of states where they cross can see these, can see both of these eclipses without doing anything other than opening their front door and going outside and setting up their refractors, obviously. And so here's the area. We see then the states that are involved. We see the cities of St. Louis, Louisville, Kentucky, Cincinnati, Nashville, and various others. The Mississippi River here, and these pink lines indicate state borders. And so the first one from 2017 we see crossed right through St. Louis. So people in northern St. Louis didn't see a total eclipse. People in southern St. Louis did see the total eclipse, and the Great Gateway Arch, just on the west side of the Mississippi in downtown St. Louis, just barely saw totality. So it was a happy arch. Then we have the 2024 one, which is a longer eclipse with a wider path of totality, as you can see here, and it crosses in this area. And so there are 4 states here in which people can will be able to have seen 2 total eclipses within 7 years. And my understanding is that it was actually reasonably clear in this area for on August 21, 2017. Who knows what it'll be like in April? April is much more challenging for weather for North America, for sure. And here what we see is that this the dimensions here 126 kilometers and then 208 kilometers in sort of length. And so it's a much larger area within which people could see both of these eclipses than it was in 70 and 72. And we also see that the durations have some real difference. First of all, in 2017, it still was an under 3-minute eclipse. It was more than either of the ones in 70 or 72. It was 2 minutes 40 seconds totality at this location, but the sun's altitude was way higher. And not surprisingly, it was just in the afternoon, as you can see, at 13:21 Central Time, daylight time. So the sun was very high. In 2024, one of the reasons this is being called the great or really great American eclipse is that the duration of the total phase of the eclipse along almost all of its path exceeds 4 minutes. That's a long eclipse. The longest that is possible mathematically in this epoch is 7 minutes 30 seconds. We don't see that in our lifetimes, that's for sure. And the sun will be up very, quite high, 56, 57 degrees at this location. So that's going to be a really interesting eclipse to see. And then finally, to those 2, we're going to add the annular eclipse that I just talked about. That'll be visible across the U.S. This coming October. And so to remind you, that's the path of this annular eclipse. And so it will cross the US and Mexico. The closest distance, and I can tell you because I'm already planning to be there if I can, driving distance from Toronto to the center line of this eclipse is 2,800 kilometers. And my plan right now, if I can get the time and get away from various court hearings, is to go to observe just a few kilometers outside Roswell, New Mexico. Gee, no one's ever heard of that place before. that's where the center line passes, just 30 kilometers outside downtown Roswell. So we put the other two eclipses that we were talking about on the screen here. And what we can see is that the 2017 eclipse and the 2023 eclipse crossed here over the ocean, the Pacific Ocean. And not unobservable, but probably no one will have seen that. But here in Texas, these two paths will cross. And already the towns located there have websites. They're talking about themselves. In addition to being cowboy capital of the world, one of them is within this little diamond shape. They're also eclipse capitals of the world. Who knew? And so here we have Texas and northern Mexico. And here we're seeing already the advertising that is taking place on various websites. This then is the path of the annular eclipse this coming October. And we can see that it's actually fairly wide. It passes right over Corpus Christi, which is right on the coast. I have a backup observing site there. And then this then will be the April 2024 eclipse. And so we see here that there's a nice diamond-shaped area within which both of these are going to be able to be seen under the great skies of Texas. Well, Texas is going to have its cloud problems as well. It's too bad that the best weather is actually going to be in Mexico. Be interesting to see how many Americans want to try to cross into Mexico on eclipse morning to see that eclipse. And so what we see here then is 187 kilometer width here, 211 kilometers here, and you can do the math and figure out that this is a fairly large area. It's interesting that for the total eclipse, again, the southern limit passes almost directly right through downtown San Antonio. And so people in San Antonio will want to live, real estate prices will probably go up, in northwestern San Antonio, so they'll see the total eclipse. In southeastern San Antonio, they'll see a very large partial eclipse, but no corona. And here we see that these eclipses both exceed 4 minutes in length. The annular one, 4 minutes, 50 seconds, which is a long one, with the sun conveniently about 46 degrees up in the sky. And then in the April one, it's early in the eclipse path, and so it's just a little bit afternoon. The sun is even higher, it's 67 degrees, and that duration here at this location is 4 minutes and 26 seconds. So a lot of people are talking about going to Texas. I've been thinking about that myself actually for many years, sort of trying to figure out exactly where we're going to be observing. And so I'm going to stop there. This is just a little composition of 3 of my photos from the 2017 eclipse. And I am simply going to say thank you. Hope you've enjoyed this, and it'll prompt some thinking, about the geometry of eclipses and so on. And Paul, I don't know whether there's any time. There may not be any questions from me either. Anyway, I've enjoyed presenting this to you, and I hope you've liked it.
Thank you, Michael. Excellent presentation. Lots of interesting detail and quite timely. Even though these eclipses are months away, it does take time to prepare travel plans. So thank you for reminding us of these eclipses. Let's see if there are any questions online. Emma.
Hi, yes, we got a question from online coming in from Ron McNaughton. Michael, I've seen 2 eclipses, 1999 and 2017, from close to the center line. Are there things which can be better seen while closer to the edge?
Well, first of all, hi, Ron. It's nice to, Ron, I've known each other for decades, I think. And yes, it's a very good question. And the answer is yes. Most people gravitate to the center line, and I do myself, because that's where the duration of totality is actually maximized. When you get toward the edge, you can imagine that the moon is being displaced a little bit, further and further away from the center. And when you get to the edge and then just outside the edge, it's not a total eclipse at all. And so just at the edge or just slightly inside, the total phase of the eclipse is very short. It can be only a second or a very few seconds. But what you do get and you can often see, is so-called Baily's beads. I'm not going to go into all of those, but those are essentially, those are rays of sun breaking through the valleys on the limb or the edge of the moon. And you can see those Baily's beads for a much longer period of time. If you're on the center line, you can see them for just, and I know this because I've watched them several times, just for a very few seconds before totality starts. And then when the moon moves off on the other side, you can see them for just a very few seconds. If you're near the edge of the path, you give up a lot of totality, but you can see those Baily's beads for up to 20 or even 30 seconds if you're located at the right location. So that's one of the main things that I think is probably the greatest difference, Ron.
Well, that's really cool. Thank you so much. That's the only question we got online.
All righty. So,
any more questions in the room? No questions. Michael, I have a question myself. In the beginning of the presentation, you described a fourth type of eclipse.
Yes.
I've never heard of that before, ever.
Okay, what I'm going to do, let me, if I may, and I think I can do this probably fairly quickly. Sorry, maybe I can't. All right, so it's a hybrid. It's a so-called hybrid eclipse, and so let us think of it this way. If we think about and let's say the sun is up there, and we have the curved surface of Earth, and the moon's shadow then is going to cross Earth from, hitting the western side of planet Earth, then crossing the planet, and then off to the east and into space. When it hits the western side, the shadow hits the western side, it's at a part, it'll hit Earth that is further away than when it then crosses to where the sun's directly overhead. This part of planet Earth is going to be closer to the sun than this part where the shadow first hits. And so if the moon is at just that point of its orbit, where it just barely covers the sun, as seen when the sun's directly overhead, when the moon's shadow hits here, the moon is a little further away, and it won't quite cover the sun. So that'll be it'll be annular, a tiny, tiny, razor thin ring of sunlight. Then as the shadow races across for those further east, the moon will start to appear bigger in the sky, and at some point it will cover the sun completely, and there will be a region here in the path that will experience a total eclipse, but very short, only a very few seconds at most. And then the same thing happens as the shadow moves across to the eastern side of the planet, and it gets further away. The moon gets further away, and it reveals again a razor thin ring around the outside. Those are so-called hybrid eclipses, and you can imagine just from my description that they don't happen very often anywhere.
All right, so I think there are no more questions here. Michael, thank you so much for presenting to us once again, and we look forward to a future presentation.